Hello. Welcome to the lesson focusing primarily on how to convert degrees to radians and vice versa. Now, before we get started, we need to talk about what radians are. Now, you have the definition before you. All it's saying is that it is an angle, but instead of degrees, we use radians, which is in the form of pi, focusing on the radius of a circle. Now, why do we care about radians? Well, it's because when it comes to solving functions with real numbers, that's where radians comes into play, because degrees is not usually the best option when solving problems. But here we're going to focus mainly on how to go between one and the other. So for the first thing is how to go from degrees to radians. Well, what you do is you take the degree, multiply it with pi over 180, and you just simplify. So let's go straight to our first example right here, where we have 45 degrees. Well, what you do is you literally just take 45 and multiply it with pi, and then make sure that you put it over the fraction of 180. And then you ask yourself, how can I reduce this fraction? What are both numbers divisible by? Now you try to go as large as possible for both cases, and in this situation it is going to be 45 itself. So the top is going to leave us with 1 pi, or just pi. But as for the top, 180 divided by 45 is going to be 4. So therefore, our answer for this one is pi over 4. Then we go to the second example, and we say, alright, take negative 270, multiply it with pi, and put it over 180. And then we say, alright, what is it reducible by? In this situation, the largest multiple we can divide both two numbers by is 90. So on the top, we're going to be left with negative 3 pi over 180 divided by 90 is 2. That's the best way to reduce this. Therefore, our answer is negative 3 pi over 2. As for the last one, just like all the other problems, we take each problem, multiply it with pi, and we just say, alright, what, divided by 180, and we ask ourselves, what is each number reducible by? It is 30 in this situation, so we're left with 11 pi over 6. And that's our answer. That's all there is to it. So what I would like you to do is go ahead and practice these examples on your own. So take the time to pause the video here. When you're ready to go, check your answers with the work I'm about to show you. So pause and resume. Hopefully you did the work. So here's the work for each one. Again, not much work to show. All it is that you just, again, multiply each thing with pi over 180. And then you just reduce it with the largest number possible. If you don't find the largest number to reduce it with, you're going to have to keep reducing until you can't go any further. So that's all there is to it, from degrees to radians. Let's go to how to find out going from radians to degrees. So in this situation, you flip that fraction. You actually are now going to multiply by 180 degrees over pi. So let's go to our first example. You're going to multiply 180 degrees over pi. Oops. And then what you do is you just literally multiply across and multiply across on the bottom. So this is now going to be 180 degrees pi over 3 pi. But here's the thing, pi divided by pi is just equal to 1, so really they cancel each other out and you don't really need to worry about it. Now you just say, alright, what's 180 divided by 3? And your final answer is going to be 60 degrees. That's our answer to that problem. Then you do the same thing with the second example. Multiply both top and bottom. You do 180 degrees on the top, and on the bottom is going to be pi. Alright, now, to save some time, because we're multiplying two fractions together, if you see a common factor, top and bottom, you can just go ahead and cancel it out without having to actually multiply it. So the pi's can cancel each other out at that point, again, because pi divided by pi is 1. But let's multiply the numbers across. And I want to put an equal sign from earlier because that makes me feel better. Alright, so this is now going to be a negative fraction. And we say, alright, what's 180 times 5? You say it's 900. Which makes the degrees. On the bottom is 6. And then now you just simply reduce it. And perfectly divisible, which means that 900 divided by 6 is going to be negative 150 degrees. Because remember, the final answer is still negative. Oops. So there you go. As for the last example, again, multiply the top by 180 degrees. Multiply the bottom by pi. And you cancel out the pi's immediately without worrying about it. And then now you just say, alright, what's 180 times 9? And you say, oh man, that's a really big number. 1620. We're all divided by 4. So thankfully, this one is also perfectly divisible. So our final answer is going to be 405 degrees. Oops. 405 degrees. And that's our final answer. So that's all there is to it on that front from going from radians to degrees. So go ahead and go to the next slide here and practice on your own. Try to see how you can convert radians to degrees. When you're ready to check your answers, go ahead and resume the video now. Oh, I guess it doesn't work that way. Pause, then resume. Alright, here is the work for radians to degrees. Again, notice I multiplied everything by 180 over pi. I didn't show the step of crossing things out, but hopefully at this point you know that the pi's just cancel out. And you just have to focus on the numbers. And that's all there is to it, ladies and gentlemen.